I'm here with Josh Hooks. He's a senior applied scientist at Amazon Robotics, and I'm here to interview about his job.
Awesome.
So tell me a little bit about your current job.
Yeah. So right now, right now I wear mainly one hat. I've worn two in the past. So right now I'm the tech lead for the beta phase of our project. So it's a Vulcan stove. So it's a project that's trying to robotically stow items into these shelves to store the Amazon inventory. And so what a beta tech lead means is essentially I manage the technical direction of the program. So I'm deciding on which features we want to work on to ensure that we deliver the product. And then the other thing that I've worked on is what we call the matching algorithm. So it's essentially the high-level planning algorithm to determine which items go where and how the robot is going to stow it. And so those are kind of the two things that I've been involved in.
And what does your typical day-to-day look like?
Yeah, so my typical day-to-day right now, going from into that beta tech lead kind of role is a lot of meetings, a lot of planning meetings. So I meet with almost all of the teams because I need to know which features, not just from our software teams or our science teams, I need to know across the board. And so I go through a lot of decision docs, planning meetings, status updates right now. But that kind of swings in my career. So when I did more of the match planning or the match high level algorithm, a lot of my time was spent coding, testing on the robot, getting ready for those sorts of tests. And so right now, a lot of meetings, previously a lot of development time.
And what would you say is your favorite part about your job?
So I actually love this project. So I helped to start this project. And I think the thing that is so unbelievably cool about Amazon and kind of just robotics, what I got interested in robotics is seeing something go from concept to actually doing the thing that you want it to do. And so, and I think the thing that I really appreciate about Amazon is the scale at which you get to do that task and the purpose that it has. So, I really enjoyed my PhD, but one of the things in my PhD that bothered me a little bit was a lot of the work that I was doing, I knew was never going to leave the lab. I knew, it was that one video, that one time, and doesn't work 24/7. What I love about this project is we have to make it do that hard task 24/7. It always needs to work, and I really like that purpose. And so this project drives me, and it's probably the thing I like the most about my job is just that I feel that the work I'm doing is very impactful.
And what was your path to get to this job? Like previous jobs or education?
Yeah.
High school maybe?
Yeah. So, I guess there's a couple things. I'll even start with the ones that aren't so flashy. So actually, I grew up in a small town, and it was a farming town, and so my high school jobs were farming. And actually, that's probably where I got interested in mechanical engineering. I will say farmers can literally fix anything with an engine. And so it was cool to watch that and got me interested in mechanical engineering. I then, I focused in mechanical engineering at University of Washington. I took it was a controls class, but essentially a robotics class, and I was hooked. After that, I didn't really know what area I wanted to go in. The minute I saw that, I knew that's what I wanted to do. All of my classes were focused in robotics and controls. I then did an internship for NASA, and so that was a robotics focused one. Kind of just kept going in that area. After college, I worked for a subcontractor for Boeing and Airbus. It was called Electro Impact, where I have to say for a 22-year-old, it was pretty cool what they let me do. I worked on these 2-3-story robots that laid up the carbon fiber parts for airplanes. They went very fast. They were very powerful. I got to really get my hands dirty. But it was about that time that Boston Dynamics was coming out with some of their videos where they kicked the spot that was actually a gas engine. You see it stumble. and it really bothered me that I didn't know how,
Yeah.
I'd taken intro controls classes and I didn't know how that worked. And it really bothered me. And I didn't think that I was ever going to get there with that career. So I decided to go pursue my PhD, where I went to UCLA and studied with Dr. Dennis Hong. He has a legged robotics lab. And it was kind of full circle. I got my PhD was my thesis was an algorithm that worked on a quadrupedal robot, and there's a video of me kicking that robot, it stumbling, and it was definitely kind of a fulfilling to kind of be seeking out that sort of knowledge and being able to get it. So
Yeah. And what would you say is like a typical entry level job in this field?
Yeah, so that's kind of it definitely varies a lot. So I think that's one thing that I love the most about robotics is that it's not just mechanical engineering, it's not electrical, it's not computer science. In order for it all to work, is you have to have aspects of all of those. And so good roboticists, they might not be deep in each one of those areas, but they have some knowledge. And so it kind of depends on what you're talking about. We have hardware engineers that have bachelor's degrees, even community colleges, those sorts of things. If you're going into the scientist route, you have to have a PhD, and so so those are really, so if you're really going into R&D, I very much recommend going in for the long schooling PhD route. But if you're wanting to just get involved in robotics, there's a ton of bachelor's in mechanical engineering, electrical, computer science. There's definitely ways to get involved in robotics.
And what like skills or experiences do you think are looked for new hires?
Yeah, so my favorite with new hires is, and what I look for, especially actually bachelor's or PhD, what I look for is, have you worked on actual robotic systems? There's a lot of stuff done in simulation, which is really cool. There's also a lot of kind of toy problems, which you can learn a lot. But the questions I ask in interviews and I ask of our new hires is, I ask questions about, have you done any signal processing? Have you cleaned a data set? There's actually a lot of fun ones, even in mechanical engineering. Like, people can design the perfect part, the perfect assembly, and when they've never actually built something is when you can't actually get the screwdriver in to turn to tighten the screw. So everything's perfect about it, the FEA, everything they did, but you can't actually manufacture it. You can't assemble it. And so those are the ones where I ask those sorts of questions, and those tell me if they've actually done robotics in the world.
Oh, so like coming out of college, like do you think they're like internships or like getting a job, like maybe not in the field, to help you get into it, or like
Yeah.
that kind of process?
Yeah. So, I mean, obviously your actual classes give you unbelievable amounts of knowledge, and we definitely look for how you did in those classes. But I always love to see, so UW has a great SAE formula. So it's the race car. They build a race car, essentially a small race car, and what that gives you is that real world experience, or internships, those sorts of things. Like have you worked on a real problem? So I love when people get involved with robotics and really go the extra mile. So it's kind of a combination of those two. Like yeah.
And in your college experience, did you do any of those like clubs?
Yeah, so funny enough, so what I did is I worked for a research lab. So I was super fortunate to get paired with an awesome PhD who, she was very kind to me, very much taught me how to publish. So she put me as a second author on a bunch of papers. Not a lot of undergrad have publications coming out. I had quite a few as a medical device, and so that really, I had to do signal processing, mechanical design. I was kind of helping her with a bunch of things. I was really good friends with all the formula guys. I helped them manufacture some parts, but I wasn't. I was. I don't know why I didn't actually join the team, but and then I did a handful of internships over the summer. I worked actually for a pipe manufacturing company doing their verification and validation testing, and then I did the NASA internship.
Yeah. And was there anything in college you wish you had done or done differently?
Yeah, it's a great question. So for the longest time, I wish I had done more computer science. So I was very much controls and mechanical engineering. So I knew how to do manufacturing, and then I had kind of classical controls background, and I've my software skill set has been built up over time. Now at this point in my career, I don't know that I think it actually gives me a pretty large benefit over a lot of scientists who only have a software background. Is I have a really good idea and understanding of dynamically what is possible from a robot. So
Yeah.
one of the biggest challenges I think a lot in robotics is people design the perfect perception algorithm or the perfect motion plan, but it's not achievable by the robot. The robot doesn't have as much dexterity as a human, those sorts of things.
Yeah.
And so I think having that knowledge of what is dynamically feasible really helps me right now. So I don't know. You asked me what I would do differently, and I think for the longest time I would have said, I should have majored in computer science or done more. At this point, I'm not sure. I think it was a long road, but I very much cherish those skills that I have in manufacturing and design. So.
And for your PhD, you did like quadrupedal robots.
Mm-hmm.
Like, how do you said you like saw a Boston Dynamics video, but like, how do you get into that topic like more engaged deeply?
Yeah, so I really sought this out. So that
Okay.
was what I wanted to do, and so it was very fortunate. My professor was just had moved to UCLA at that time, but he was really well known in the world of legged robotics, and so I messaged him. I said I want to work in your lab, and that was a very conscious choice. It was something that I wanted to get involved in, and so that was just I think that's uh, something that people just need to do. Is a lot of people I think kind of give up when they get shut down once, and it's if you really want to go do it, there's a lot of ways. You don't have to wait for someone to give you that opportunity. You can go explore that space. There's a ton of videos out there. There's a ton of open source libraries, those sorts of things. And so I just became, I really liked the community, started reading those papers, looking who are the people that I should be reaching out to. And I very much sought out my professor in that lab.
And do you have any like parting advice for someone pursuing a career in STEM?
Uh, yeah, I think it's get your hands dirty. It's I think the classroom work is absolutely essential, but it is build something, break it. Like that's where you learn the most. Is finding out what the limits of robotics is, understanding like real world latency issues. So there I could design a controller that works if I had infinite bandwidth. If all my algorithms ran in a nanosecond, I could do whatever I wanted with that. But that's not the real world, and so feeling the pain of the real world is the earlier you kind of feel that, I think you're going to be much more set up for a career in robotics.
Well, thank you very much for your time.
Awesome, thank you.